Now moving on the traversals in binary tree. Okay, so the traversal means we have to traverse the whole binary tree. Traverse the whole binary tree means we have to reach every node in a particular fashion. We have to cover all the nodes in a particular fashion. Fine. So there are the two ways of traversal. First is BFS and DFS. BFS means breadth first search. Means we have to go every node from a node we have to go to every node. In DFS we have to go from one node, we have to go another and then another, means we have to traverse depth wise. For example, depth wise traversal DFS can be this, this and this. First we are going into the depth, whereas the breadth first search BFS means we are traversing like this. The breadth wise, we are searching breadth wise, and in DFS we are searching depth wise. So first we see the depth wise search. There are three types of DFS in a binary tree: in order traversal, pre-order traversal and post-order traversal. So the in order traversal means we have to write left, root and then right. For example, the left means the left subtree, then the root and then the right subtree. And similarly, pre-order means root, left and right, and post-order means left, right and then root. So let's traverse this graph. So let's traverse this tree in order. So first we have to write the left part. So we are from here, we are from starting from root, we go to the left and then again left. Now the left of 4 has nothing, so we will print 4 because the left has nothing, left is null, and then we have to print root, so 4 will be the root, and then 7, so then 4 4 7. Fine, we have traversed this, and then again going backtracking on 2, we have we have print the left part of the 2, then we have to print 2 because this is the root, and then the right part which has null. So means we have to write 4 7 then 2, 4 7 2. Similarly 4 7 2 1, because we have covered the whole left subtree, and then we have done the root, and then we are going to right subtree. Moving on, in the right subtree again we have to follow this rule, that is first we have to print the left. So we go on the right side, we have to go left, then left we have 5, then 5 of, then the left of 5 has null, so backtrack and print 5. So we have printed 5, then root, because we know the left, then root will come, then we have print 3, and then the right subtree. In the right subtree again we have to go first left, so left of 6 has nothing, so left of 6 is nothing, then we have on root, so print 6, and then lastly at 8, because this is the 8th one. So 4 7 2 1 5 3 6 8 is the in order traversal of this graph. Similarly, pre-order traversal. In pre-order we have to write first root, then left, then we cover the right subtree. So this will be our root, we have done it root, and then the left subtree. So let's jump on our left subtree. In left subtree again we have to search like root 2 will be a root, so put 2 here, and then for left, then left of 2 means now we are on this subtree. In this subtree again we have to follow this rule, left root, then 4 will be a root, so 1 2 and then 4. Now we have done root, left has nothing, and then moving on the right we have 7, then we have printed 7 here. So we have covered yet till now we have covered the root part, left subtree, root part we have done, left subtree, then we are on right. So moving on the right subtree, first we will again follow this rule, means we have to follow this rule at every node, at every subtree. In subtree the root will be the 3, then we print 3 here, then the left part will be 5, then we print 5, and then now on right subtree. In right subtree we have 2 nodes. How we gonna print this? Right subtree, first we have to print the root part, root will be our 6, then left part which has nothing, then right part which has 8, then 6 and 8. So 1 2 4 7 3 5 6 8 will be the pre-order traversal. Now moving on the post-order traversal. Post-order follows the rule of left, right and then root. So we have to cover the left subtree first, then right subtree, and at last we will going to do print our root. So we can see that 1 will be at last because 1 is the root in post-order. Fine. So moving on the left subtree, this is our left subtree. Again we follow this rule. Again we go on the left, and then we have nothing. The left of 4 has nothing, so we are on a 4. We are 4. Left part has nothing. Then we go to right. Right we have 7. Then we go first print 7. Then root. So root will be our 4. 7 4. Complete. We have completed the left part of this subtree. Fine. Then we go to right part. Right part has nothing here, null. Then at last root will be our 2. So 7 4 2. Fine. So till now we have covered this left part of left subtree of our binary tree. Then we are on the right part. So solving this right part, again follow this rule, left right root. So left part we have 5, so we print here 5. Then right we have 2 nodes. So how we gonna print this? Again follow this. We left, on the left we have nothing, we have null. Then print right, so it means 8, 5 then 8, and then root will be our 6. Then print 6, and now we have covered 5 6 8 we have printed. Now we left with 3 because root is printing, then the root. First we have print the left, then right, and then root. Now we print 3. Now we have covered, till now we have covered the left part, right part, and we left with the root. And the root will be, we have covered the left part, right part, and covered with the root. So root will be at last. So here's the one. So the 7 4 2 5 8 6 3 1 will be the post order traversal of this binary tree. Fine. Now moving on the coding part, or you can say the implementation part. First we create the node. This will be our structure of the node. We know that this will be the left pointer, this will be our right pointer, and this will be our root. Fine. So we have data here, D. Right will be the null, obviously initialization करेंगे हम right null से, and left also the null. Okay, so we have construct our node, and here, and then this is our subtree, this is our binary tree. This is our binary tree, and have binary tree here. This will be a binary tree. This is just the code of this one. Fine. Now moving on the in order traversal. The code is similar for all the 3 traversal, just a minute changes. First we on the in order traversal. Okay, we are on the root. We have to start always from the root, then root, then we call the left part of the sub, then here we use the recursion. As we have used the recursion, so we have to find the base condition here. This will be our base condition, that if the root is null, then we have to return. This means if the root is null, then you have to return means, for example, this part has null, not example, this is actually a null. So we go left part, we go left again, we go left, we find root, then we return, and then we return, and when we return from this left, you can see the left call of the root, then we have to print. We are printing here, printing the root d means we have print the 4 here. Fine, after backtrack we print 4, and then we go on the right side, we got 7, then we got left side, we have nothing, then backtrack, then we print 7 here. We go right, backtrack, nothing, fine, nothing, and then again we go 4, we have already computed this, so will be on 2. So similarly we will print this line will ensure that we will be on the left part. It means the left here, left here, left here, nothing here, then print 4. Fine, then go on the right part, then left part, nothing, see, left part, nothing, return, print. Okay, then this will be a right part, then we go on the right part again, same thing, we go again left part, we find nothing, we print that 7, again right part, we got nothing, we again backtrack, we will on 2, and when we will be on second again we on the backtrack to 2, then we print 2 here, and then 1, because the left part in order, we have print the left part, then root, and then right part, left, root, right in order, and we have all discussed here already, left, root, right. So similarly in pre-order our rule will be the root part first, then left, then right. So root will be first, printing our root, then left part, and then right part. And in post order we have the left part, then right, and then root. So we have gone left first, then right, and then printing the root part. This will be the simple implementation of traversal. Now moving on the breadth first search. We have these all the answer means in order traversal, pre-order traversal, and post-order traversal are the examples of DFS, as we are going to depth wise first, then backtrack, then print, backtrack, then print. Now moving on the breadth first search, the level wise traversal. The level wise traversal means we have to print in level wise. For example, this is our binary tree, we have to print that this will be a level 1, then level 2, then level 3, and then level 4. So we are going to print the 1 here, then 2, 3, then 4, 5, 6, then 7, 8. So this binary tree has 4 levels, and we have printed all the 4. So what will be our implementation? Let's first find the logic. Okay, so we have to start always from the root. At root we had 1, so we have to insert. We are going to use 2 data structures here, first the Q and then the vector. Fine, first Q, then vector. this is our vector, and again we are going to use the second vector also, which store our final answer. If this is our vector, then this will be the vector of vectors. This will be the final answer here, okay, which we return after. If we are going in the function, we have covered this in the functions, like the void traversal. This function can return this, maybe, I think. So first we on the root, then we insert the root into the queue. So we have here 1, we will be having 1 here. Now the queue has 1, fine. So now then 1, then in vector we push 1, we pop here 1 and then 1 here in the vector. And when we insert it into the vector, we going to push into the queue first his one left node, left child, then the right child. It means we have to put first 2 here, 2, then 3, fine. Then this will be our one vector, will be finished here. This will be our vector, and this will be stored here. We will store it here. Then we have 2 here, we pop 2. Now we will pop 2 here, pop 2 here. So the 2 we will be on, then will be on second. It has only one child, which is left, and 4. So we insert here 4. Sorry, we will be inserting here 4, and then we go on the 3 has 2 parts, 5 and 6. So first we insert the left part, which is 5, then 6, and here we 1, then 2. 1 के बाद we have process 2 and then 3. So then 2 and 3 will be stored like here, and then here 4, 5, 6, we will be on now 4. On 4, when we are on 4s, we see on the 4 we have only one child, 7. Then we will insert 7 in the queue, fine. Insert 7 in the queue and remove the 4 will be stored in vector, and then we will process 5 has no children's, null, so we don't have to insert anything in the queue. Then moving on the 6th, we have only the 8th, which is the right child, so we insert the 8 here. So we process 4, then 5 we have processed, and then now we have processed also 6 also. So 4, 5, 6 we have processed, fine. Now we are on the 7 has no child, both null. Similarly 8 has no child, so we process 7, then 8, and there will be 7 and 8. So this will be our vector of vector, which I created here. This is not the vector of vector, sorry. We have vector of vector here. This will be a vector of vectors. This will be the individual vectors, 1, 2, 3, 4, 5, 6, 7, 8. Then we insert our answers, 1, 2, 3, 4, 5, 6, 7, 8. Here is the implementation of the code. So in this code, what we have done, first we create a vector, first we create the vector of vectors answer, which we in the variable answer we gonna store our answer, okay. If the root is null, we have to return simply, we can't do anything. And then we create a node of, then we create a queue, simple. This is our queue, queue of node star. because these all are the node. 1 is the node, 2 is the node, 3 is the node, 4 is the node. They are not the datas, no data. But in this case maybe the data and node we represent in the same way, but these are the node and nodes. Fine. Then q dot push root. First we have push the root part 1, and then this initialize the variable size here. Then I have used the while loop while the queue is not empty. So as we have discussed that in this part, when we have processed the 8 which has nothing, null, write 7 which has null, and whenever there is null we don't push anything into the root part. Fine. And when we don't insert into the root part, we don't insert into the root part. So after the removal of 8 from the queue will be emptied. So when the queue will be empty, the whole loop will stop and we have an answer ready. Answer will be ready. Fine. So the size will be the queue dot size, that is the current size of the queue, which is the 1, because we have the queue only one element, which is the root part. We have inserted only the root now. Here we have insert push. We have pushed only the root part, so the size will be current 1. Then this loop will run one time, and the node star node, we have created the another variable here, nod, which stores the front part, that is 1 is at the front now, so this will be stored in the node part. nod variable stores the front part, and then queue we pop 1 from the queue. Fine. Now we are if condition, if the node of left is not null, means if the, for example, we are on 2 part, if the 2 left is not null, which is not null, then we insert 4, and if it is null then we have done nothing. If we have is not null, then we have push into our queue, push into the queue. First the left part we have pushed, and then the right part. Similarly, if the child has right part, right child, if the node has the right child, we push the right, but we first push the left part. So after pushing both the queues, we push node data, means node data. Which node we are talking about? We are talking about the front part. Front part data will be stored in the vector VEC, and then the whole vector will be pushed after the loop here, and this will again turn, because the queues will be not empty. Queue will store 2 elements. After removing the 1, it will be have 2 and 3 as its child, because we have insert 2 here and 3 here, or 2 or 3, don't know. So again this follow, the size now will be the 2. This loop will run 2 times, and similarly the whole, at last we will be having our output like 1 2 3 4 5 6 7 8. Thank you.